In this image, what you see, apical four-chamber view, global hypokinesia of left ventricle is slightly dilated. You see the aortic valve is not opening fully. So we suspect aortic stenosis, but how much severe aortic stenosis is there? LV systolic dysfunction is because of aortic stenosis, or aortic stenosis like look is because of LV systolic dysfunction. Because of LV systolic significant dysfunction, sometimes valve is not opening properly. That will look like pseudo severe aortic stenosis, but that will look like a severe aortic stenosis, but it's not severe. Only because of significant reduced LV systolic dysfunction, valve is not opening. So appears like severe AS. So to find out whether it is severe AS or not, we apply continuity equation. Continuity equation tells us the amount of volume that goes through LVO2 has to go through aortic valve also. So volume that goes through LVO2 will also go through aortic valve. So volume remains same. So volume means same means, so volume is area into length, that is volume, equal to area into length. As you know, we can measure the LVO2 area, LVO2 velocity. The volume, we know how much volume is there that is going through the aortic valve. But we cannot measure the aortic valve area directly. In that case, what we do, we measure the velocity across aortic valve. So we have got three things: LVO2 velocity, LVO2 diameter, and aortic velocity. By putting all these things, you see here the LVO2 velocity. Valve, the sample is placed across aortic valve in continuous wave, and we calculate the time velocity integral. In this image is 63.6 centimeter. Again, we are kept pulse Doppler in LVOT portion, that is 1 centimeter inferior to aortic valve. In LVOT portion, you can measure the velocity across LVOT. Then we measure LVOT diameter, and that gives you the idea by continuity equation how much the aortic valve area is there. But one equation is there, just ratio. By ratio wise, you can say whether this is severe AR or not. So in this case, ratio is less than 25. That means velocity across aortic valve is more than 4 times that of LVOT velocity. That indicates severe AS. You can see time velocity integral here. It is LVOT is 15.7 centimeter. Next image, it is 63.6 centimeters, so almost 4 times. That is severe AS, severe aortic stenosis. If you take the diameter of LVOT, then it will give you exact area. How much area is just by continuity equation. So there are two things you get from this video. One thing, you apply continuity equation. For the continuity equation, you have to calculate velocity in LVOT, velocity at aortic valve, and diameter at LVOT, where you take the velocity. Diameter has to be taken in parasternal long axis view. In zoomed image correctly, it should be taken correctly, because diameter is, if you make little bit mistake will become bigger, because diameter is squared in this equation. So that has to be remembered. So you have to take correct diameter. Then you will get the area of aortic valve by continuity equation. Second thing is that even if you don't get LVOT diameter, even then by ratio you can say whether this is severe aortic stenosis or not. LVOT velocity and aortic velocity. If velocity of aortic valve, at aortic valve is more than 4 times that of LVOT, that indicates severe aortic stenosis. Just by velocity ratio, you can say, or VTI ratio, you can say this is case of severe aortic stenosis. So in this case, velocity across aortic valve is almost 4 times that of LVOT. So this is the case of severe aortic stenosis, and severe LV systolic dysfunction is because of severe aortic stenosis. That is the point to know. So you can find out this is the case of severe aortic stenosis, and LV systolic dysfunction is because of severe aortic stenosis. You can see the aortic valve is not opening, almost not opening here. This is because severe aortic stenosis is here, severe aortic stenosis is here, and LV systolic dysfunction is also here.